A ball is chosen at random from each of the 5 urns if the urns contain balls with different colors as follows. So in each urn there's a distribution of white and black balls. We need to find the expected number of white balls selected, right? So what we're going to use, I'm going to let x1 number of white in urn 1, x2, x3, x4, and x5. So we're dealing with 5 random variables. Okay, same thing, same thing, same thing, same thing. Urn 2, urn 3, urn 4, or urn 5. Okay, so we need to find the expected number of all of these random variables together. So we're going to add the expected number of 1, expected number of the second variable, plus third, plus fourth, plus fifth. So we need to find each of these expected values in order to find the expected number of white balls selected, right? So, expected value of random variable 1, right? So, as you know, the expected value is the value, right? The summation from k is equal to 0 to n, right? Times k times the probability of k, right? So what it basically means, if we select 0 white balls out of the first urn, we're going to have 0 times the probability of 0, which is in hypergeometrics is given by this, choosing 0 balls out of the white, choosing 1 ball out of the 5 black, and dividing it over by the all possible choices that we can have, right? 6, because there are 6 balls in total in urn 1, choosing 1 from the 6. And then the second case that we have to add, because it's mutually exclusive, right, these cases, is going to be choosing 1 white. So we multiply that. Basically k stands for these two values, 1 and 0, and the probability of 1 white from the first urn is from 1, we choose 1, right? From one white we choose 1 white, 1 ball, and then from 5 black we choose 0 balls and divide it over by the total. And that is equal to what? That is equal to 0 plus 1 over 6, right? Because 6 choose 1 is 6 combination 1, which is 6. 1 combination 1 is 1. 5 combination 0 is 1. 1 multiplied by 1 is 1, right? So it's 1, 6. The second one is similar. I'm going to go right here. So again, choosing, so we can actually disregard this because it will always give us 0 because of the k value of 0, right? So we can disregard the choice of 0 white balls in each of the remaining cases because it will just be 0 because of this 0. So we can start with choosing 1. So that's going to be 1 times, now here we don't have 1 ball, we have 3 white, so we choose 1 out of 3 and 0 out of the black, divided by how many balls in total? 6, choosing 1 out of the 6. And that's it, right? That's going to be 3 over 6, right? Because everything else is 1. 3 choose 1 is 3, 6 choose 1 is 6, 1/2. Perfect. The second, the next one, expected value of the third urn, choosing 1 ball from the third urn, expected value, right, of the number of white balls out of the third urn. Again, we can disregard the first case. Taking 1 white will give us what? It will give us from 6 white you choose 1, from 4 white you choose none. And by the way, we can disregard this case as well. We don't have to use we don't have to write choosing out of the black, because it's always going to be 0 and that will give us 1. So we can disregard it. Actually, we can just leave it like this, right? What's the total number? 10. Choosing 1 out of the 10. So that's 610, which is equal to 3/5, right? Now, what's the expected value of the white balls in urn 4? Again, just take one case, choosing you're gonna have to multiply 1 by, right? So I should say 1 by, but we can disregard it because it's not gonna change the answer. Choosing 1 white, right? So choosing 1 from 2, and we don't have to do 6 choose 0, because in each of those cases it was equal to 1, right? So we don't have to write it. Divided by the total. What's the total? 8 balls, right? So choosing 1 out of the 8. That's going to be equal to 2 over 8, which is 1/4. Excellent. And the last one, the expected number of white balls chosen out of urn 5. So let's see. So again, we don't have to even write 1 times. I will just write it for the sake of this formula, because k value has to be present there, so you know. 1 times, and now the probability. So what do we have? Choosing 1 out of the 3, right? 3 choose 1. We don't have to write the black. It's going to be equal to 1. What's the total number? 7 plus 3 is 10 balls, right? So choosing 1 out of the 10, right? So that's going to be 3, 10. Perfect. So now we have our values, our 5 values that we can use to find the expected value, the expected number of white balls selected, right? That's going to be 1/6 plus 1/2 plus 1/4 plus 3/5 plus 3/10. Right? So as you can see, the least common multiple of these denominators is 60. Right, so 6 got to be multiplied by 10, so we get 10. 2 has to be multiplied by what? By 30 to give us 60, right? So plus 30. 4 must be multiplied by 15 to give us 60, so 15, right? 5 must be multiplied by 12 to give us 60. 12 times 3 is 36. 10 must be multiplied by 6 to give us 60, so 3 times 6 is 18. So if you do this, 40 plus 15, 55, plus 36, 91, plus 18, that's 109. 109 over 60. So that's your expected number of white balls selected. Hope this was helpful. Thanks for watching, and I'll see you in the next video.